Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will try to use the trigonometric substitution to solve the integral below. Before I start solving it, I just want to remind you of the formula for trigonometric substitution. If you have square root of a square minus x square, usually we take x equal a sine of theta, and we usually use that formula. Cosine square of theta equal 1 minus sine square of theta. Because sine square of theta plus cosine square of theta equal 1. That is a trigonometric identity formula. And if we have square root of a square plus x square, we take x is equal a tan of theta, and we use the trigonometric identity formula. Sec square of theta is equal to 1 plus tan square of theta. And if we have square root of x square minus a, we use x equal a sec of theta, and we use the trigonometric identity formula tan square of theta equal sec square of theta minus 1. This is like a reminder. In that video that we will solve, we see I have 16 plus x2, so it looks like I'm gonna be using this formula here. But yeah, so I know a square plus x2, but 16 is 4 square, so I can use it. So let's start. I say this is outside this is an explanation, this is outside solving this problem. I'll keep it like that. Let x equal, instead of a, in that case it's 4 tan of theta. So my dx is equal 4 sec square of theta d theta. So now my integral was integral of x to the power of 3, and the x is equal 4 tan of theta. So my integral become, I replace x by 4 tan of theta to the power of 3. Square root of 16 plus 4 tan of theta square. And instead of my dx, we said dx is equal 4 sec square of theta d theta. So that would be my integral now. Now I know 4 to the power of 3 is 64, so my integral become 64 tan to the power of 3 theta square root of 16 plus 4 to the power of 2 is 16 tan square of theta times 4 sec square of theta d theta. Now I can put 16, I have 16 common between the two additions, so I factor out 16. So my integral becomes 64 tan to the power of 3 theta, and if I factor out 16, I can take it outside the square root as 4, 1 plus tan square of theta. Because here I factored out 16, it becomes 16, 1 plus tan square of theta, and the 16 went outside the square root as 4, and I kept inside the square root 1 plus tan square of theta. And then I have 4 sec square of theta d theta. But I know 1 plus tan square of theta is equal to sec square of theta. And as I said here, we usually use sec square of theta equal 1 plus tan square of theta. So I'm gonna replace this by sec square of theta. So my integral becomes 64 tan to the power of 3 theta times 4 square root of sec square of theta times 4 sec square of theta d theta. But I know square root of sec square of theta is sec of theta. So let's do it right away. We save a little bit of time. So now if you multiply 4 times 4, 16 times 64, you will have 1024. So I'm gonna write it 1024, which is 64 times 4 times 4 equal 1024. I'll put it outside my integral, and the 10 to the power of 3 theta, I'm gonna write it 10 to the power of 2 theta, and then I will put besides it sec to the power of 2 theta. So I wrote 10 to the power of 2, sec to the power of 2. I still have 10 theta sec theta d theta. If you look at it, it's the same thing as that integral here. And now I know that 10 to the power of 2 theta is equal sec to the power of 2 theta minus 1. So I will replace 10 to the power of 2 here by sec to the power of 2 theta minus 1. So my integral become 1024 integral of sec to the power of 2 theta minus 1 times sec to the power of 2 theta times tan theta sec theta d theta. Here I can say let u equal sec theta. So my du is equal tan theta sec theta d theta. Tan theta sec theta d theta. It's a formula. You learned it in Calculus 1. The derivative of sec theta is tan theta sec theta. So here my integral become 1024 integral u square, because we said u equals sec theta, and I have here sec square. So u square minus 1, and that sec square become u square, and then my du become tan theta sec theta d theta. So tan theta sec theta d theta become my du here. And that become easy now. So my integral become 1024 integral of u to the power of 4 minus u to the power of 2 du. And that's easy to solve. 1024, it become u to the power of 5 divided by 5 minus u to the power of 3 divided by 3 plus c. But here we said u is equal to sec theta. We took it, where did we say let u equal sec theta? Here, I was looking far away. Let u equal to sec theta. So I will replace my u by sec theta. So my solution become 1024 sec to the power of 5 theta divided by 5 minus u to the, minus sec to the power of 3 theta divided by 3 plus c. Yeah? Now I will draw my famous triangle, and in my triangle this is my a, which is equal to 4 in that case, and this is my x here, and here it is square root of a square plus x square, which is 16 plus x square. And I know sec theta is equal 1 divided by cos theta. So let's do cos theta here. Cos is equal the adjacent divided by the hypotenuse, and that's my theta. The adjacent of the angle theta divided by the hypotenuse of the angle theta. So my cos theta is equal 4 divided by square root of 16 plus x square, and so 1 divided by cos theta, which is sec theta, it become square root of 16 plus x2 divided by 4. So now I will replace my sec theta here by 16 plus x2 divided by 4. So my solution become 1024. I open my parentheses. I had sec to the power of 5 of theta. So square root of 16 plus x squared divided by 4 to the power of 5 and divided by 5 minus, it was sec to the power of 3 here, sec to the power of 3. So I will replace sec by square root of 16 plus x2 divided by 4 to the power of 3, and all that is divided by 3. Yeah. So my final solution become 1024 divided by 5 multiplied by square root of 16 plus x2 divided by 4, all that to the power of 5. I will take out the parentheses, I will multiply it directly, minus 1024 divided by 3 multiplied by square root of 16 plus x squared divided by 4 to the power of 3. And that, plus c. That's the final answer. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.